we can understand the strength of the interactions between cations and anions using Coulomb's law. So the Coulomb force in this context is proportional to the positive charge of the cation and the negative charge of the anion, and inversely proportional to the squared distance between them. So for example, if we consider calcium chloride, the calcium cation has a 2+ charge, and each chlorine anion has a negative charge. And if we compare this to sodium chloride, with the cation has a +1 charge, and the anion has a -1 charge, then the calcium cation in this case carries a 2+ charge compared to the sodium cation. So the interaction between the calcium and chlorine ions is stronger than the interaction between the sodium and chlorine ions. And the other governing factor is that the calcium ion has a smaller ionic radius than the sodium ion. So the distance between the centers of these ions is smaller than the distance between the centers of the sodium and chlorine ions. So therefore, the interactions between the calcium and chlorine ions are again going to be stronger in that regard. And recall that you can determine the trends in the ionic radii using the periodic table as we've done previously.